Here we go. Fractions with different denominators. I'm probably going to spell denominators wrong. Denominators in one-step equations. OSE. One-step equations. So far, we've seen examples like this. X plus 3 1/3 equals 2 2/3. Something like that. Actually, we haven't seen it. Let's do 1 1. So the first step would be to subtract this number that's by x. You guys are getting really good at this. Leaving x alone. And then 2/3 minus 1/3 is 1/3, and 2 minus 1 is 1. We've seen a lot of problems like this. What happens though if our denominator over here, let's say it was 4/5, is different than our denominator over here? Let's say I had 3 9/10. What am I going to do if I have two different denominators? Well, the first step is still the same. Okay, you guys still know this first step. Subtract 2 5/4. 4/5. Leaving x alone. But now when we go to subtract this, we can't take 4/5 away from 9/10. So we have to get a common denominator. We have to ask ourselves, how many tenths is 4/5? Or we might have to change both of them to a new denominator. Okay. So the way we do this, let's just do kind of an example on the side. If I have 3/5 plus 2/10. The thing that I have to do is change my denominators to be the same. I have to ask myself, what is the least common multiple of 5 and 10? Does anyone know what that number would be in this case? Not 2. I'm looking for a number that 5 and 10 can both go into.
1.
So let me show you how I would do this. 5 goes into 10, which means my least common multiple is 10.
Are we allowed to...
So I want to have both of my denominators be 10. Both of my denominators need to be 10. But I can't just change this to 10, right? If I multiply this by 2, I get 10, right? So that means that I also have to multiply the top by 2. What is 3 times 2? 6 tenths. So 3/5 is 6/10. These are the same thing. Now over here I already had 10, so I'm just going to leave my numerator. Now I can add these. I have the same denominator. So I can add these. 6 plus 2 is 8. 10 is the same, so 10. But now I need to reduce again. 8 and 10 both have a 2 in them. So I'm going to reduce my 8 to 4, my 10 to 5. And so my final answer would be 4/5 after I divide them. Let's do a couple more examples. 3 fourths plus 1/8. Does anyone see a number that both 4 and 8 could go into?
2.
It's always going to be a number that's bigger.
Or 8.
8. They both go into 8, right? Yeah. So here, how many times do I have to multiply 4 to get 8? 2. So I'm going to multiply the top by 2 as well. I'm going to have 6/8 plus, this one stays the same, 1/8. So my answer will be 7. Okay, what about if I had one like this? 1/2 plus 1/3. Let's see. So far it's just been the bigger number. But does 2 go into 3? No. 2 doesn't go into 3. So I have to find a number that they both go into. 6. They both go into 6. So I want my denominators to be 6. How many times do I have to multiply 2 to get 6? 3. So I'm going to multiply the top. How many times do I have to multiply 3 to get 6? 2. And multiply the top. So 1 times 3 is 3. 1 times 2 is 2. And so 1/2 plus 1/3 is 5, 6. Now let's come back over here and look at this problem. I have different denominators. I have 9/10 and 4/5. Right now we're totally ignoring the whole numbers. We don't really need them yet. What am I going to do? What am I going to change here so that I can add, so I can subtract those? Yeah. Uh-huh. Exactly. So this is going to be 8/10. Now I can do this. 9/10 minus 8/10. How many tenths do I have? 9 minus 8 is 1. And 3 minus 2, I have a whole number of 1. That is my final answer. You can reduce it. Yeah, you will always be able to, but if we did, then we'd have to get tenths again. Right? The whole reason that we wanted to get tenths was so that we could combine it with this. Now, you are picking up on a trick though. Let's look over here. 3/5 plus 2/10. Can one of those be reduced? Which one? What could we reduce 2/10 to?
1/5.
1/5. So sometimes it's easier to reduce. Right? Because then what we notice, 3 plus 1 is 4/5. We got to our answer a lot faster by reducing rather than by increasing the number. Okay? Alright. So that's pretty much it. Let's do 3 examples. Okay. We had y minus 2 and 1/4 equals 3 and 1. And then if we had w plus 1 and 6/7 equals 3 and 1/10. And what if we had m minus 2 and 2/3 equals 3 and 5. Alright, I'm going to walk you guys through these. First step. Add 2 and 1/4. What do I immediately notice? I have a half plus a fourth. I don't have the same denominator. What can I do to get the same denominator? Multiply which by 2? The halves, right? If I multiply the halves by 2 over 2, that's going to be 2/4. Now I have 2/4 plus 1/4, which is 3/4, and I have 3 plus 2, which is 5. And that's my final answer. Okay. Let's take a look at this one. I'm going to subtract 1 6/7. W is left on this side. Okay, I have 14ths and 7ths. What's my lowest common denominator?
7.
Well, I can't get 14 down to 7, but I could get 7,
I know.
7 times 2 up to 14. So now I have,
Is it always going to be 2?
no, 12 14ths. Good question. I should do one that's not 2. We'll do some other examples. Now what happens though? Look, 1 14th minus 12 14ths.
You have to borrow.
Now I have to borrow. Okay? So sometimes that's going to happen where you have to borrow. 2, how much did I borrow? I borrowed 14 14ths. I already had 1, so how many do I have now? 15 of them. 15 minus 12, how many 14ths do I have left? 3 14. And I have 2 minus 1, what's my whole number? 1 and 3 14ths. All right. First step here, add 2 2/3. Just m is left on this side of the equation. I don't have the same denominator. What is my lowest common denominator? Between 5/6 and 2/3. Multiply this one times 2. So now I have 4/6. What is 5/6 plus 4/6? 9/6. And what is 3 plus 2? 5. Wait a second. What am I going to do?
Divide 9 by 6.
And what am I going to get? You guys look at that and tell.
1. 3, 1.
So I'm going to pull out a 1. So what will, when I add my 1 to my 5, right, I have 5, and then I have 6/6. And how many left?
7.
I had 9. I'm going to pull 6 of them out.
That's 6. Right?
Right, so basically this adds to 6. And then 3/6. Oh, one more step. So I have 6 and 3/6.
6 and 1.
Exactly. 6 and 1/2. Because my 3/6 can be reduced. So my final answer is going to be m equals 6 1/2. So in this one we had to add that number back in, right? Convert from an improper fraction, and we had to reduce our fraction.
That's the long way of doing it?
Sort of, yeah, we could have like just divided, right? Like you guys did earlier. We could have just done 9 divided by 6. 6 goes into 9 once. 1 times 6 is 6. 9 minus 6 is 3. And we would have taken this up here and have 1 and 3/6. That's another way, and then add that on to our 5. And then we get 6 and 3/6 that way, and reduce to 1/2. I don't think either way is necessarily longer in this case. Your homework will be problems like this. I want to do a couple examples like Shelby said, because right now you're thinking, oh, it's always multiplied by 2. So let's do some that aren't. Okay, so example 1. What if I had n plus 2 and a half equals 3 and 2/3? What if I had z minus 1 and 1/3 equals 2 and 1/4? And then for the last one, this is a weird letter like k. K plus 1 and 1/5 equals 2 and 3/4.
Why does like the letters have to be fancy?
I always try to make the letters a little fancier just so they don't look like numbers. Like if I just drew a quick Z, it looks a lot like a 2.
Yeah, and like if you did an X, just regular X, that would look like.
X kind of looks like time, so sometimes I'll draw it like that. Yeah. I don't necessarily always do it, but when I remember, I try to. Okay, first step. You guys are going to walk me through these ones.
Subtract 2 and 1/2, that's going to cancel out to equal n, and then you subtract it to the other side too.
Okay, so I have n equals. I don't have the same denominator, no!
8 1/2.
What am I going to have to do to make the same denominators here?
6.
Good, someone saw it. My denominator could be 6.
6.
Okay. 2 times what equals 6? 3. So I'm going to multiply the top. So 1 times 3 is 3. Okay, 3 times what equals 6?
2.
So multiply the top. 2 times 2 is 4. Oh, I could reduce this. Do I want to though? No, because then I won't have the same denominator anymore. Okay, so 4/6 minus 3/6 is 1/6. Don't forget about your whole numbers. 3 minus 2 is 1. And we're done. How about this one? First step.
You add 1/3 to both sides. And then it'll just be by itself, and then you equal it, and then
Okay, what is my common denominator now? Between 4 and 3. One trick is that you can multiply the two numbers together and you'll always get a common denominator. What is 3 times 4? 12. So let's just do that. 12.
Oh, okay.
So what do I have to multiply 4 by to get 12?
3.
Uh-huh. So in the top we're going to have 3. What do I have to multiply 3 by to get 12?
4.
So in the top here, what's our numerator here?
4.
4. I like to cross these out so I don't get confused. This is my new fraction, right? So I'm done with this one. What is 3/12 plus 4/12? 3 plus 4 is
7 12.
7/12.
And
And I'm done, right?
No. Have to do 2 plus 1.
Don't forget your whole numbers. 2 plus 1 is
3.
3. Can I reduce 7/12? Wouldn't that be like 3/6 or something?
No.
No, not quite.
Has to be even.
Yeah, it would have to be even. Okay. K plus 1 1/5.
Minus 1/5.
Minus 1 1/5.
And then those would cancel out. That'll be fancy K.
Fancy K. Equals, okay. 3/4 minus 1/5. Uh-oh.
Hold on.
Well, yeah, 20, right? Let's just multiply 4 times 5. That will always work. Now, sometimes there's a lower number. In this case, though, I don't think there is. So 20 is going to be our lowest number that we could get. So what did we multiply 4 by to get 20? So what's our numerator? Just 5, right?
No, because you have to multiply 3.
We have to multiply it by the 3. Very good catch. So 3 times 5 is
15.
15. Is
Same to the bottom.
and then what do we multiply 5 by to get 20?
24.
What's 1 times 4?
4.
4 20s. 15 20s minus 4 20s. How many 20ths do I have?
You
15 minus 4.
is 11.
11.
20.
20.
20. And then
I'm done, right?
no.
No.
You have to
You're
subtract
not,
2
Nate.
minus 1.
Subtract 2 minus 1. 1. Can I reduce it? 11 over 20?
No.
No. Cannot be reduced. And that is that.
If it was 22, yeah.
Do you guys have any questions?